Some of them are going to be more important and used than others. Some of you are already used. However, it's just going to, it depends on what exactly you're doing. Most of the time, there will only be one or two that you use. I will go through these. I will explain them. Some of them, however, the explanations, we have to go into some higher level calculus stuff to go back and prove these properties, which are then assumed. They used to assume properties and then work through it. Mr. Sororzano would have a fit about it. We already had this discussion yesterday where you assume a property is true in order to do something, and then you go back later and prove it. He likes to prove everything step by step by step by step. Kind of depends on what you want to do. It's a little interesting kind of discussion. So let's go for the rules of order of integration for integrals. So for this one, if we are going on the integral from a to b of f of x dx, what do you think would happen if I flipped where we're going from? If I took the a and b and I flipped them around and going from b to a.
Oh, it's like a derivative.
Huh?
Is it like a derivative or something?
Luke?
Would it like switch it to polarity, like make it negative?
Exactly. If this answer was positive, it would become a negative. So when you switch those intervals, if we switch this from 11 to 9, we would just flip it to become negative. Okay? What's the reasoning for that? It's because you're calculating the area from left to right, not right to left. Calculating left to right. Then right to left. It's just, it's kind of like what, I like Luke's description, you're switching that polarity. Okay? Now, how about this? What is the area under the curve from A to A of f of x dx going to equal? It is going to be equal to 0. Very nice. Why is that? Well, remember, integrals in the end are area. What's the area under a single point, a one-dimensional point? It's 0. There is no area. The next one, if I have from B to A of k f of x dx, it is going to be the same as writing this out as k times the integral from b to a of f of x dx. If I have something that's multiplying the function on the inside, I can just pull that out and multiply it at the end and not have to deal with the bigger numbers. So if we had to say oh, what's the integral of 50x? Well, what could we do with the 50? We could take it and put it on the outside, take the integral of x, which is much easier, smaller numbers, and then multiply that final answer by 50. All right? All that this does is k is a vertical stretch. Slash shrink, which means it's going to basically just increase the area of whatever you're multiplying it by. If our area was 2 at the beginning, but we're multiplying everything by 2, the equation by 2, then obviously we'd multiply the area by 2. All right, the sum and difference. Now this one is a little bit hard to understand at the beginning. Let's say I had the integral from b to a of f of x minus g of x. I had two functions on the inside of an integral. And you're like, well, how do I do this with two functions? Kind of remember derivatives. When we take the derivative of something that's adding to another derivative, do we take the derivative of the whole thing or just one and then the other? One and then the other. So therefore, the same is going to be true here. This is going to be equal to the integral from b to a of f of x dx plus or minus the integral from b to a of g of x dx. Oh, sorry, write plus or minus here also. Not minus, plus or minus. It's true for both positive and negatives. Okay. The reasoning for this is that you add / subtract vertically. This explanation, I don't love this explanation. It doesn't necessarily make a lot of sense, is what the book says. But again, the further down we get, the less and less we use certain ones of these. Okay. I'm going to actually skip additivity for a second. I'm going to go down here, and we're going to talk about ones that I don't love these, but we're just going to mention them. The minimum value of f in between b minus a. So the minimum value on that interval of b to a is going to be less than or equal to the integral from a to b of f of x dx, which is less than or equal to the maximum a to b f of x dx. Oh, sorry, sorry. The maximum function of b to a. All this does is it sets up a range of values, for f of x. Now, I can go back to additivity because for some reason I did not copy it down in my notes, which is kind of ridiculous of me. Foolish. Now, if I go from the integral from a to b of f of x dx, and I'm adding the integral from b to c of f of x dx, I want you to take a second and consider what this could be equal to. If I go from a to b and take the area under the curve, and then b to c, take the area under the curve. Cody?
It's just the integral from a to c.
Yeah, exactly. It's the integral from a to c of f of x dx. It's not necessarily redundant because let's say I gave you 7 integrals to do, and you have to take the integral over and over and over again of the same function, but then you realize, oh wait, this one and this one is just one range. This one and this one is just one range. This one and this one is just one range. Oh, they're all just one range. So sometimes they might ask you to do integrals of like little areas, and you realize, oh, if I just do the integral of the whole area by combining them, it's just writing down what you might think is obvious, but might not be clear to others as well. Like this might be clear to you, for others it's not though. Okay? Translate. Add horizontally. What I'm saying there is you're smart for seeing that, Caleb. Good job.
Okay.
Good job, Caleb. Everybody, a little applause for Caleb over here. Okay.
Caleb.
Now, oh boy. Let's say that f of x at some point is greater than g of x. What this tells me, if f of x is greater than g of x, then the interval from a to b of f of x dx is going to be greater than the interval from a to b of g of x dx.
Is it an arrow? Or is it an equal sign with a greater sign?
Just an arrow.
Hold up, let me
That's the way
just
teachers
zoom
do
in.
it.
Is that a greater than equal to or question mark? What is that?
There's a greater than,
Why do teachers draw arrows like that?
because that's how they do it in the. That's how they do these in the books.
Oh.
So because like I try to like a lot of these notes are copied over from the books. That's much
because they
better.
can't
That's an
type
arrow?
an arrow.
Huh? That is yeah. That is very true. You have to do equal sign and then greater than.
Just do a
Just draw an arrow. So you can draw an arrow, so you don't have to do
I refuse.
that. Okay.
No.
I didn't do it in my notes. I won't do. I'll stand on that principle. I didn't do it in my notes. I won't do it now. All right. This one also larger functions will have larger values. Now, let's go over really quick which ones you're going to need to know pretty well. First of all, this one, pretty important. Definitely know that one. Order of integration, know that, oh, if we flip the interval, or if we're ever going from a smaller, if we go from a small to a bigger number, usually the area will be positive or negative depending on where it's at. But if you ever go from a bigger to a smaller, if you go from right to left and not left to right, that's when you have to flip it. This one here, if you're going from one number to the same number, it is going to always be equal to 0. Here, constant multiple. You don't necessarily need to use this all the time. However, it is useful, so I'll put this here. It makes your integration easier as you move along. Sometimes it might also make it harder, though, and we'll see that as we get into anti-differentiation. Sum and difference, this one is important. Yes, definitely know that one. Additivity, know that one. These two down here, not as much. You don't really need to know those as well. Okay?
What's the squiggly line?
Eh.
Kind of know it.
You should know it, but you don't have to use it all the time.
So. Okay.
Yes. If you see what's the integral of 1,1252x, you can just pull out the 1,252 and then take the integral of x and then multiply that final answer by 1,252. It makes it easier. But sometimes when we get to the point where we're integrating, it will get harder if you continuously do that with your constant multiples. All right, now let's go ahead and talk about the average value of a function on an interval. I know you all, like me, have wondered, well, this is a crazy graph. What's the average value of the function? Like, how would you find that?
All the time.
All the time, right? It's pretty interesting to think because, it's like it goes, so for some of them, it's like, okay, well, linear, it would just be in the middle of it. But what about if you have like a cubic or a quadratic or something like that? The average value isn't going to be the bottom or the top. It's going to be somewhere on the graph. And with integration, we are given this formula here of 1 divided by b minus a times the integral from a to b of f of x dx. Okay? So, what I'm going to do now is show an example with this. All we need to do is find the integral from one point to the next, and then divide that by 1 over the distance from b to a, which you find by doing b minus a. So, first things first. First step is to integrate. We're just going to do the integral first. So, set up your integral real quick. What is my integral going to be? Ben, can you help me write it out? The integral from what? From where to where?
A to B.
Which is?
0 to 4.
0 to 4. What's my function?
2 minus x squared.
2 minus x squared dx. Now, on the homework, you're going to use Calc 8. However, I'm going to show you something interesting. See, now I want to draw an arrow, but I want to stick it to you all, so I want to draw really, this weird arrow here, so I'm going to do that, like that. Just looks terrible, right? It looks like a sideways smiley face. Oh, man. So I'm going to draw that out. That looks a little better. So the integral here. Can anybody tell me what the integral of 2 minus x squared is? Just the integral of 2 minus x squared. Does anyone know that real fast?
Wasn't that? Yeah. Is that something you see?
We haven't necessarily done this, but if you did 18 on the homework yesterday, you might have seen something interesting. Not 4. We're not going to plug in anything yet. We don't input anything.
We skipped it.
Yeah, we skipped it. Yeah.
Some people did it. Emily, do you have it?
It's like the antiderivative.
It would be the antiderivative. So here, what I'm going to write this out as is 2x minus x cubed over 3 from 0 to 4. Now, how did I get 2x should be pretty clear. Remember, when you do the antiderivative, you're just doing the opposite. What's the derivative of 2x? 2. What's the derivative of x cubed over 3? X squared. Just go opposite that way. We will practice antiderivatives, don't worry. This is just me kind of getting us started on that thought. Okay? So, what you can also do is, especially on the homework for tonight, I would encourage you to try the antiderivatives out. But you can also use Math 9. Woo. So go ahead and do Math 9 real fast in your calculators. I will write this out for you all if you want to also copy along here.
So should we not do Math 9?
You can write it out. You can write this out, but Math 9 is what you're going to use on your homework for now. This is a good initial practice if you just want to see how it's done.
So do we plug in the antiderivative or do we put in the function, the original function?
The original function.
Okay.
This is me after I've already taken the integral.
I see.
Why did you?
Oops, so this is
You plugging in 2 or 4?
The intervals.
And that's the average?
that right there. No, not yet. We don't have the average yet. That is the area under the curve. Then what I'm going to do is I'm going to take negative 40. The second step is take negative 40 over 3 and multiply that by (1 over 4 minus 0), which is going to equal negative 40 over 4 times 3, which is going to equal negative 10 over 3. So what is the y value what is the average y value on this interval going to equal? Negative 10/3. That's like the middle point, which is strange to think about. It's a different way to think about it, again, because as we get into these calculus problems, average value is not necessarily going to mean, oh, add the two together, divide by 2 or 3 or 4. We're going to be using this integral trick. So just remember, you take the integral from a to b of f of x dx and then just multiply that by 1 over the distance. I'll have Connor, can you write that up on the board real fast for me? Or, sorry, Connor's over there. Oh, geez, I don't want Caleb to. Never mind.
Okay.
Do you want to? You can.
No.
Go ahead, do it. You can write it. You can write it. We got it.
Great, you got it.
Caleb,
What am I doing?
Just copy down the average value formula. Okay.
one of
Right.
the one over
Just
b
now.
is a
Now.
interval.
One thing to note here is that negative 10 over 3, is that our x value or our y value? This is the y value. So if I ever asked you, find the x value. Yes, question?
Why are you plugging 4?
For where? For here?
No, for the, like, instead of using 4, but why did you plug in 4? Did you plug in the farthest point?
For this one,
Yeah.
No.
for here,
Yeah.
I plugged in both. See? 4 times 4 minus 4 cubed
Why did you choose 4?
minus 2 times 0 minus 0 cubed. Because that's what they asked you to do.
So like the bigger one, like B goes first and then
Yes.
A? Okay.
No, sorry, no. A goes, so this one will always go first. Sorry, the B goes first, yes. We do the farthest, we do the big minus the small.
Okay.
Big minus small there. We will walk through this again. This is an extra step that you haven't seen before, but this is how you would do it. Do the integrals there. So, to find the x value, so, Faith, what was the question there?
Yeah.
Oh yeah, Emma?
So, like, we've been doing it where you just plug in the integral into the original function.
Mm-hmm.
So, how do you know when to do that, or when to plug it into the antiderivative?
So you mean when you've been doing it in your calculator, you mean? You've been doing like this, 0 to 4 of this value here, and you would put it into your calculator, or you would graph it out and put it into the function and stuff?
Yes, like the next step when you inputted 2 times 4 minus 4 cubed over 3. Like, how do you know when to do that and when to just do 2 minus 4 squared? Like,
Oh, okay, yeah. Because when we do, this is again, this is a topic that we're going to talk about later on. But when we find the area under the curve, the way that we're doing it right now is we're saying this here is the area under the curve, right? Which means we need to find this point and this point, correct? When we do the antiderivative, we get a different kind of function. And again, we're going to learn this tomorrow. We're going to go over exactly how. But the antiderivative is basically going to be the same thing as the integral. So the antiderivative is equal to this. So if I find the antiderivative, then I don't need to do the area under the curve. Okay? It's a different way of doing integrals, which we're going to learn later on. Okay? So if that doesn't fully answer your question, that's okay. You will for now, for the next while, don't do this right here. If you want to try the antiderivative, you can. You don't have to. Okay? But does that make a little bit of sense?
yes, but it would get you a different answer then, right?
If you like, what did you get when you did that? When I did it, what did you get?
If
Here?
you do it the way we've been doing it, like with
Math 9?
you would get negative 13.3.
Yeah.
But then your answer is negative 3.3 for the negative.
Oh, well, because we have to multiply it at the end by this. Multiply that by 1/4.
Oh.
There you go.
Okay. Okay, thank you.
Yep, you got the same thing.
No.
What?
0.83.
Yeah.
No, you multiply. Wait, do math 9 times 1/4. So do math 9.
Oh, I thought you meant, okay, yeah.
Yeah, so you should get negative 10/3 here. All right,
Wait, why are we doing times 1? Yeah.
because that's the average value. For the average value, you have to multiply it by 1 over b minus a.
Gotcha.
Okay? All right, now to find the x value, all we would need to do is take 2 minus x squared, which is equal to 2 minus x squared. We want to set that equal to our y value of negative 10/3. And then all we need to do from there is just find this out. So we get solve for x, negative x squared equals subtract by 2 there. So we do negative 10/3 minus 2 or minus 6 over 6, which is equal to negative x squared equals, that's negative 20, minus 6 over 3. Negative 16 over 3, this becomes negative 16 over 3. And I'm gonna keep messing up all the time, don't worry. X squared is equal to 16 over 3, therefore x squared equals the square root of 16/3. And you can rewrite that as, x equals the square root of 16/3, or equals 4 root 3 over 3, and that would be our x value. So at 4 root 3 divided by 3, we will get our average value. So the point that the average value is at 4 root 3 divided by 3. Yes? Faith?
So what you plug in for x again?
For here,
Yeah, for 2 minus x, right?
you didn't plug in it, we're looking for x. We're finding the x value. So here we take the y value, set it equal to the equation, and then solve for x.
Okay.
Where'd you get the 6 over 3? 10 over
Subtract by 2. Oh, where did I get the negative 10/3?
Oh, wait. Okay, now the 6 over 3. Okay, so you subtract.
Okay, got it?
Yes.
Actually, yes?
When you take the square root, don't you have to take the square root of the bottom too?
Yes, I did. I jumped too much. I'm sorry, I jumped too much here. Sorry, Isaac, explain it to Abby, please. Just, you can do that. Okay. But anyway, when we did the square root of 16 over 3, that is the same as 4 over root 3. And then 4 over root 3, we would multiply by root 3 over root 3, and that gives us 4 root 3 over 3. I just skipped from there to there without showing that work. Okay? All right, so your homework for today is going to be 1 through 6. 1 through 6. Okay? Tomorrow we will start the next exploration, and then I probably will do the next exploration the next day. I'm a little sad that we're missing it. For these, do not do the antiderivative yet. All you have to do is Math 9 for now, and then we'll work on the antiderivative in the next. That's going to be after the quiz that we get into antiderivatives. Yes, you may go. All right? All right, everybody. Say goodbye to Isaac and Evie.
Bye.
Smoke bomb? Oh, yeah, I just disappear like that. There we go.
Ah.